Welcome back to the Data Show. I'm your host, Detective Diana. My mission is to teach you how to do what I do best, solve mysteries. If you know how to seek evidence, evaluate data quality, and reason to a solid conclusion, you'll be less confused, less swayed by the voices trying to persuade you of this or that, and you will know your decisions are good ones. Today, we're discussing the scientific method, the strength of data and having lots of it, and causality. We'll provide stories and real-life examples to show you how experiments test theories, how collecting lots and lots of data and replicating the results increases certainty, and how reasoning can help you solve mysteries faster, even save lives. Oh, and one more thing before we get started. If you haven't already attended your data detective orientation on evidence-based reasoning, check it out before today's training. Here's a quick teaser for the day. Scientific methods can empower human endeavors and improve performance in many ways, including in sports.
In 2002, Billy Beane was a young new Major League Baseball general manager for the Oakland A's, a very bad team at the time. Even with one of the best sluggers, Jason Giambi, they started the year with many more losses than wins, and they kept losing the American League Championship to the Richie Rich New York Yankees. Giambi even pulled up stakes and joined the Yankees for $120 million over 7 years, 3 times more than the Oakland A's total player budget. Along came former player and economist Paul DePodesta, Billy Beane's assistant general manager. DePodesta adopted sabermetrics, which applies the abundance of baseball statistics to figure out who to hire. The data suggested an unpopular strategy to hire workaday players with reliable statistics, people who could get on base even if they didn't have star potential or didn't look amazing to scouts. These players not only routinely contributed to wins, they were financially undervalued and thus affordable for the struggling A's. Applying this analysis, by 2002, the A's won over 100 games, won the American League West, and broke a record with 20 consecutive wins. Sabermetrics are now widely used in Major League Baseball and many other sports, including ice hockey and basketball. Thank you, data. This story was made famous by the movie Moneyball, which was based on Michael Lewis's book on the topic.
So, as you can see, data are not only important for testing theories and saving people with science and medicine, they are important for other real-world decisions, from picking shoes based on an AI suggestion to selecting good detectives for 3-letter agencies in Washington. Either way, to rely on evidence or data, you have to be sure it's high quality. Not all evidence is created equal. Good evidence is collected or produced through careful, repeated, reliable observations or scientific experimentation. You don't need a PhD in chemistry or statistics to make sense of the world, but it helps to know a few key things about data, how it's collected, and how to interpret it.
Scientific method. The process of objectively establishing facts about the world through observation and experimentation.
These definitions are sometimes abstract. Let's watch a demonstration from our friends Lion and Monkey to help us understand the concept better.
Lion.
And Monkey. Ooh, ooh.
Rawr. What you doing, Monkey?
Studying for my driver's test on Friday.
Aw, you've been doing that all summer. How hard can it be?
I mean, I know how to go on green and stop on red, but they want me to memorize facts, like the number of seconds to drive behind someone, or a school zone speed limit.
Well, that does sound tricky. Hey, maybe you could record yourself and play it back while you're sleeping. I hear people learn French that way.
Lion, I don't think that's actually gonna work, so I'm just gonna read and reread this book until it fixes itself in my monkey brain.
Well, suit yourself.
Thank you, Lion and Monkey. So we can solve this problem with the scientific method. In order to know how to use the scientific method or to evaluate someone's research, we should quickly review what exactly the scientific method is.
What, you ask, is the scientific method? First, you want to identify your question. In the case of lion and monkey, they want to know which is the most effective way to study for a test. Ideally, you are testing a very specific hypothesis. For example, that one thing that should work better than another. So in the case of our friend Monkey deciding how to study for the driving test, Monkey's hypothesis seems to be that rereading the material would be effective. Lion thought maybe passive listening to the material while sleeping would work. To decide which hypothesis is correct, we would need to do research and collect data and see how the results come out. We are lucky here because, as it turns out, scientists have actually studied how to study for a test. For example, in one study, local university students were told to read a list of words and study them for a test later. Some were told to just read and reread the list like Monkey was doing. Others were told to read the list and underline words that were harder to remember, similar to the way that students often highlight in their textbooks. The final group was instructed to read the list and test themselves on what they read. After the three groups took the test, the scientists used statistics to analyze the data. When they compared the test scores of the three groups, they came to the conclusion that students who tested themselves remembered more than the students who just read and reread the material or who had just underlined the text. Later, many scientists over the years have replicated those early results, confirming that self-testing is more effective than rereading when you are trying to memorize information like a list of words. The fact that the results were replicated makes us more confident that the results are real. Someone should go tell Monkey.
Fascinating. Before we go on, though, let's make sure we're all on the same page about what data are. Fun fact, the word data is Latin, so it's actually the plural form, and scientists say datum when there's only one.
Data. Pieces of information that we collect and combine to improve our understanding of the world.
So when there's consistency across lots of data from many sources, we can feel more confident that Monkey will score higher on the written driving test by self-testing compared to rereading or playing tapes. Let's check in with Lion and Monkey to see if they found a solution. Take it away, you guys.
Hey, Monkey. I did some research into the science of learning. It turns out scientists have figured out how best to learn this stuff.
I hope it's fast, because the test is in 14 hours.
Yeah, well, scientists compared different ways of studying, and they found it's best to test yourself rather than to just reread. Yeah, reading helps recognize information, but not recall facts, or pick the right answer when they're all familiar.
So staring at a page for 2 hours didn't help?
Well, maybe switch now and start testing yourself. I have some note cards for you. Write the question on one side and then try to guess the answer that you wrote on the other.
Is this based on high-quality science? I can't waste any more time.
Yeah, there's dozens of scientific studies testing thousands of participants. They found that self-testing generally outperforms rereading. And they found it was better for learning arbitrary facts like how close can you park to a crosswalk?
20 feet! I'm glad I didn't just keep using the less effective method. Thank goodness for good science and good friends. I hypothesize that I will pass this driver's test. Thanks, Lion.
Figuring out which ideas are supported by evidence isn't always easy. Ideally, you can find and examine the data or a summary of someone's data. But data come in many forms, and they aren't always collected objectively through recommended methods or with enough trials. Some people even report their personal experiences as compelling data, what scientists call the N of 1 phenomenon. We want to look for data collected by more than one group, using different approaches, which inspires confidence that the results are solid enough to take to the bank. Literally.
Hey, Ted, how's the farmer's market?
Hey, not bad. I had a bumper crop this year for my zucchini. I sold out of the vegetable, but strangely, my zucchini-infused potato vodka wasn't moving.
Huh. I wonder maybe people are drinking less? I heard college students binge less nowadays.
Bad timing for my passion project, I guess. But I I did look it up on the National Institutes of Health website where you can find the information for free.
Ooh, great resource, Ted. So what did it say?
Well, it turns out you're right. Like on Mad Men, alcohol used to be a symbol of fun, but people started to worry about the health risks in the 80s.
Yeah, remember how many cigarettes Don Draper smoked? I imagine it's not good for your health.
Yeah, the research is strange though. So, in the early 90s, scientists said that people in France who drank red wine lived longer, and they were healthier than people who didn't. They said drinking about 2 glasses of wine per day reduced coronary disease by 40%.
Whoa, that's a lot. How?
Well, they thought the wine could inhibit platelet reactivity, especially because red wine has antioxidants that improve cholesterol.
I also know that red wine has resveratrol, which is thought to reduce heart disease, high blood pressure, and diabetes. Did it replicate?
Seemed to. In 2000, another group reported that moderate alcohol consumption reduced heart disease and diabetes.
So, make wine.
No, the saga continues. Even newer and larger studies found that wine didn't benefit health or longevity. It can even be bad for your health.
How so?
They studied 28 million people in 195 countries. People who drank even 1 drink a day had a higher chance of substance abuse disorder, road accidents, self-harm, and some cancers. Men, especially over 50, were more likely to have liver cancer and tuberculosis.
So I'm in the clear.
And women over 50 who drank were more likely to have breast cancer.
So that's why my doctor said it's better maybe not to have any alcohol. Why the flip-flopping?
Well, like you always say, data are a more the merrier situation. Plus, alcohol research is hard because people aren't always honest about drinking. And we can't make people drink the way we would with rats. It's not a controlled experiment. And even a controlled rat study wouldn't perfectly mimic humans. We aren't all from one genetic strain, and we all live varied lives. Lots of behavior impacts health. Things like where we live, what we eat, and how much we exercise.
True. Cross-sectional research.
Where data are taken from lots of people at a single point in time.
Can't make causal claims. For that, you'd need an intervention that follows people over time.
Right. Like my uncle. He doesn't drink, but he's super unhealthy because he used to drink and smoke a ton before he gave it all up. Or my friend Inez, who doesn't drink and is super healthy, but she exercises constantly and only eats raw vegetables.
Exactly. So a correlation in a large population doesn't seal your fate, and large studies can produce significant results from small effects.
True. There were only single-digit increases of some of those specific cancers from drinking. Without a predisposition, it is far from certain you get that from drinking.
So maybe don't drink in excess, but be especially careful if you have a predisposition toward addiction or liver or breast cancer.
Or if you're pregnant.
Oh, right. Alcohol's effects on a developing fetus are proven to be much worse.
And of course, never, ever drink and drive.
Good call.
But an occasional, safe, Mad Men themed party with zucchini-infused potato vodka can increase neighborhood bonding in a way that might outweigh the risks.
We do know that socializing increases longevity, so at least find ways to be with other people.
Like you!
Thanks for dropping by, Ted.
Yeah.
I'm guessing Monkey also learned about the value of friendship this week. Ted brought up some really good points. Sometimes it seems like scientists disagree, which naturally happens because each experiment is different. Occasionally, the results of research show a really big effect that is unmistakable and we should respond quickly. but many times the effects are small and only appear in large studies of the population. There are also often confounding factors that can alter results, like the fact that people who report not drinking might be a recovering alcoholic or might be super healthy in other ways. Considering the causal story for how one behavior influences an outcome really helps us to determine when evidence is solid.
Causality. A relationship where one event systematically impacts another.
If one event directly leads to another, then causality is probably involved. But most events have multiple or indirect causes, which makes it tricky to decide. If you took healthy rats and only added alcohol to half of their lives, and the drinking rats got sicker than those without alcohol, you could assume causality. But you can't assume when it's just a correlation between events in a large group of people living different lives. Here's a great historical example of when causality was used for good to solve an important, devastating health mystery: cholera.
The place, London. The time, 1854. A man named John Snow dug deep into the evidence to discern the cause of a virulent disease that was sweeping London. He changed the world of epidemiology forever. Something horrible was happening on the streets of London that summer. People were getting sick. Lots and lots of people. The victims couldn't keep liquids down and soon died of dehydration. In just 10 days, 500 people had dehydrated themselves to death. The disease was called cholera, and it was taking London by storm. What confused scientists most about this outbreak was that most cases were happening in Soho. They believed that diseases were transmitted through air, and Soho shared air with the rest of London. So why weren't other people getting as sick? Enter John Snow. Snow wanted to know what caused certain people to get sick and not others. So he studied patterns in the case and collected data to figure out the true cause of the outbreak. Turns out, it was only the people who were drinking London's water who got sick. Londoners who stuck to beer made from a different water source were perfectly healthy, or at least didn't get cholera. He proved it by collecting data from doctors around the city and mapped out the locations of every person with cholera. Look at the pattern. All of the cases were huddled around a single water source. Every victim seemed to have gotten their water from the Broad Street pump. At first, other scientists were reluctant to believe Dr. Snow. Their theory about diseases being only transmitted through air was very helpful when they were studying pneumonia and the flu, so they responded to Snow with criticism and ridicule.
Please, listen. This one is a waterborne contagion that induces vomiting.
Your face induces vomiting. What my associate means, sir, is that we've known for years that diseases are transmitted through the air. Diseases can't survive in water. They would drown.
I agree that some diseases move through air, but look at these maps. I traced and plotted all of these cases, and they all surround the Broad Street pump. When my colleague, Reverend Michael Whitehead, talked to the citizens living around the pump, he made a disgusting discovery. A mother with a sick child was washing her son's used diapers in a cesspool near the water pump. Guess what her child was sick with? Cholera.
This story has a happy ending. Everyone came around to John Snow's evidence-based theory about the cause of cholera. The leaks around the water pump at the center of the outbreak were repaired. The pump was replaced a few years later. London's entire water system was rebuilt with hygiene in mind. John Snow dug deep into evidence surrounding the common factors between people who did and did not get cholera and saved thousands of lives. He created maps from the evidence and created the field of epidemiology, which tracks disease by looking for similarities and differences across people who do and do not get diseases. We can learn from Snow not only to use this method, but also to consider how even knowledge we already possess, like airborne disease transmission, might need to adjust to new information. We have to stay open to objective evidence, which helps us reach the right conclusion in the long run.
So, John Snow collected lots of data and applied causal reasoning. He determined that the victims drank from the same well, which was also contaminated by a bacteria-filled diaper. We learned a whole new way to get sick. Thank goodness for modern plumbing. Whew, that was a lot for your first real day of data detective training. Remember, anyone can be a data detective. Just generate a hypothesis, collect lots and lots of data, and reason toward a possible cause. See y'all next time. Case closed.